right? On the Google form, make sure and fill out the proper email, right? So when they add here, right, and they will add it to the subject, right? All they do is make it fill out that email, right? Right. So today we're going to take a look at solving inequalities. Right? We're going to take a look at solving inequalities. Right. Before we go into that, right? You all remember when we solve something like this here. When we solve ax squared plus bx plus c, right? Equal to 0. What do these answers represent? Whenever you solve the quadratic equal to 0, these values represent something. It's of what? Yeah. Coefficients. When you solve this, anybody online? When we which one? All x-intercepts. So whenever we solve the quadratic equal to 0, we solve for the x-intercepts. Let's call it alpha and beta. Okay, so whenever we solve equal to 0, we obtain these two values. So what that simply means, you all remember what I call this x-axis? So let's call this x-axis. There's an equation for it. Y is equal to 0. Very good. So for solving a quadratic, whenever we solve y is 0, we're really solving for alpha and beta. You okay with that? So today, we want to move away, and you're going to remember how to solve this, right? Factorize or use the formula, and then in case it into calculator, right? Okay with that? So the problem now is that what do we do? What do we do for that? What do we do if I said, well, solve? What do we do if I say to solve ax squared plus bx plus c is more than 0? Or if I say to solve ax squared plus bx plus c is less than 0? How are we going to solve this? Right? Equal to 0 is here and here. Everybody okay with that, right? Where is y is more than 0? On this graph, where is y is more than 0? Huh? Y, but where is more than, this whole thing is the y-axis. Where is more than 0? Top part, right? Where is y is less than 0? Bottom part. Right? Look at the graph. You all seen the part of the graph that is more than 0? Yeah? Come on, show me, Jack. Where is the part of the graph that is more than 0? At the part? Right, so here and here, and which part is less than 0? Right, but on the graph itself, that part. You see that? Very good. So this part of the graph is more than 0. This part of the graph is less than 0. Okay. So what you will recognize, unlike when it's equal to 0, is just two values, right? When it's more than 0, it's all of this. All of this. You see that? When it's less than 0, it's between here. Right? So if I ask you to solve a quadratic when it's more than 0, all you have to figure out is the part above. How do I get the part above, Dominic? Real easy. To get the part above, that's here. All we have to do is take all the x values less than alpha. See that? All the values here, giving you something more than 0, right? All these x values here, giving you y values more than 0. Correct? And all these values more than this. Right? All the values more than beta. All these values here. Any value more than beta, giving you this y value here. So if I combine all the values less than alpha and all the values more than beta, if I combine them by using union, I have my solution for this. You're okay with that? So the solution for this, right? The solution is ax squared. So the solution for this is x is less than alpha together with x is more than beta. Online? You're okay with that concept there? Yeah. Serena, are you okay with that? So these are your solutions, right? Online, are you okay? So again, a guess. What would be the solutions for less than 0? What would be the solution for less than 0? Anybody? Online, you can mess with everything you have it. What do you think would be the solution for less than 0? X is less than alpha, more than alpha. So all the values, more than alpha and all the values, less than beta. Can I write it like this? Can I write it like that? All the values more than beta, more than alpha, less than beta. That's okay. So this is how you solve the inequality. Right? So what are the steps? So step number one, in order for us to solve it, you all recognize that I drew a what type of quadratic here? Maximum n. What is this? What shape is this, Dominic? Minimum or maximum? Minimum, right? So once minimum, because the rules will change if it's maximum. Okay. So once minimum, step number one, find critical values alpha and beta. Step number two, do a quick sketch. Right, do a quick sketch. And number three, write the appropriate solution. Right, one more thing that I have to highlight is that when you're doing your sketch, you have to shade the appropriate region. So if it's more than, you're shading up here. If it's less than, you're shading down here. Right? I'm gonna show you how to handle it. Right? So you sketch your quadratic and you shade. Okay? We have three steps. Step number one, once it's a minimum, you find alpha and beta, sketch your quadratic shape, like a solution. If it's not a minimum, I'll show you how to, and I will add some suggestion just now. All right? Well, you know, once you remember the graph, it should be, remember everything above is more than everything below is less now. I'm gonna give you some numbers now to like make some sense, right? If you're confused, I'm gonna put some numbers now. I'll make it down. I'm going to show you on some number, right? So those are 3 steps. While you're waiting, anybody can figure out what to do with the maximum? Again, not us yet. That's why example and minimum. Right, so these rules only hold for minimum. Then one spot. There is something called article. I thought again, injection of say. Just go together. They do go. Right, all kind of thing that is looking at this. Yes, yeah. Yes. It's like going by some blocks. Block out or something. Huh? I check all kind of things. Huh? Well, that's going on, but there is still everywhere is grew up and there. Was it in the middle of like it? One thing long. All right. So let's try one. All right, so we're following these steps. All right, I hope you all remember how to get alpha and beta, right? That's one of the important things that you have to remember. So let's try an example. Example number 1, right? Let's see if we can solve this. Let's see if we can solve x minus 1 by 2x plus 1 is more than 0. First thing first, I need to make sure this is a minimum, right? So I am just going to multiply this up. So I'll get 2x squared plus x minus 2x minus 1. X by x, x by 1, minus 1 by 2x, minus 1 by 1, right? And then I'll realize that I have 2x squared minus x minus 1. And this is a minimum. This value here is more than 0. Now, step number 1, once it's minimum, is to find the critical values. I don't call them solutions anymore, I call them critical values, right? So the critical values are alpha and beta. So all I have to do, right? All I have to do is go to the calculator and solve them, right? Plug it in the calculator and what you get. Plug it in fast. Or you can factorize and solve, which is kind of what we have here already. So remember that? So you could factorize this just like this and solve it. X minus 1 is 0, 2x plus 1 is 0. Check this out. So you're supposed to get minus a half and 1. Children, you remember this? You sure? So it's minus a half. Polynomial 2. Polynomial and then go to 2. Online, solve it quick, away you got. So you're solving this equal to 0. So forget the inequality sign. Okay, minus half. Right, remember to plug in A is 2, B is minus 1, C is minus. Yeah, okay, nice. Shia, you're okay with this? Matisse, Serena, you're okay with this? Right, so that's just solving it, right? Now, watch here. I'll write this out. Just make sure you understand what to do. After you get the critical values, the next step is to do a quick sketch. You don't want anything else but this on your sketch. You're cutting at minus a half and plus 1. So just do this. Nothing else matters. right? We turn in white, nothing matters. Minus a half and 1. Now for the most important part before you write the solution. Where to shade? More than 0 means we shading where? Above, right? More than 0 means we shading above. We can't shade in the middle here, we just shade in here. Right? And then, because it's more than, write the solution. The solution is x is less than minus a half together with x is more than. That's all you have to do. X is less than this, x is more than this. That's okay? Put the smaller value first and the larger value out. So okay with that? Right? That is your solution. But you can't write this without doing this because it wouldn't give you any marks. Some schools will do a table method where they will choose values until they figure this out. I don't like that because it'll take a little while. This is a nice standard method to use. But you can't write this without this. Okay? Try number 2. Make sure it's on the number, right? What's the graph now? Thank you. Yeah. Let's see. Any answers online? I saw one. Right, three are sending not the critical values, right? Send your final solution. Online, right? Send your final solution. Like what I have up there, send your final solution. Right. Dominic? Remember, you have to be diagram and shield, right? Yeah. But not for me, one of them. Next to not. Right, so to work out this here, we check it to make sure, so I'll get 5x². 15 minus 1 is 14 minus 3. Yeah, and then when you solve it, you will get your critical values. Critical values are x is equal to -3 for the smaller value first, and the larger value out. Right? -3 and +1. Do a quick little sketch. This is -3, this is 1. Right? It's not really to the scale, right? But the most important thing is that you highlight these two where you touch the x-axis. And then the question was less than 0. So I am going to shade where it's less than 0. And then write my solution. X is between -3 and 1/5. If I have less than or equal to, all I will do is that. Okay, just include less than or equal to, and it's simple. Are you okay with that? Serena, are you okay with us? Notice before I solve, I always have 0 on the right hand side. That's okay? So before I solve, I always have 0 on the right hand side. Right, let's try next one. This one might not be nice values, right? It might get bad values, right? What's the first thing to do here, Dominic, with this one? What's the first thing to do? Right. But before we do that, before we can check it, we have to make sure that this side has what? 0. So what do I do with this one? Pull it across. Right? Then check and see if it's minimum and then move it up. What arrow? Oh no, that's more than or equal to arrow. You can solve it. Right? Alright. Everybody here know the group, right? It's supposed to be on, right? Online, everybody was her group, right? Right, so this is minimum. This is minimum and the critical values are what? One and negative one and one fifth. Right? Negative one fifth and one. Yeah. Right? So usual thing, do a quick little sketch. Here's negative one fifth. Here's one. Question said more than or equal to zero. So we do our shading here. So x is less than minus one fifth. X is together with x is more than or equal to one. Okay? Yeah. Right. We have this big problem earlier. We have a problem now if it's a maximum. What do we do? So suppose we have something like this. Right? Suppose it's maximum. Suppose I gave you something that was a maximum. Minus 5x squared plus 4x plus 1 is more than or equal to 0. Suppose I ask you to solve something like this. Right? If we go ahead and solve the critical values, you would get that, right? But it wouldn't be shaped like this. So you have to learn about a new set of rules. But I don't want you to learn anything else. I just want you to learn what I showed you earlier. How I can convert this to a minimum. How I can convert this maximum to a minimum. Move the close state. Something else you could do. The close state. So you're trying to get this positive. So how you can get it positive? Add what? Huh? What you can do? Anybody online? What we could do to make this, or what we could do here to make this minimum. Negative 1. Right? So multiply negative 1. Right? So if maximum, multiply by negative 1 to turn it into a minimum. What you do here though? Change the sign, right? So more than will become less than. Okay? So please remember to change the sign. Right? Remember to change the sign. And then go right ahead and finish it out. Okay? So the next step, find the critical values. Critical values is the same question from before. So the critical values are the same. Right? Minus 1/5. 1. Where do I shade? Where do I shade? Less than, right? So I shade in between. And that's it, the right solution. All right, and then I write the solution. So if it turns out to be a maximum, Serena, all we have to do is multiply by minus 1. And then go ahead and do it normally. Serena, you there? Shreya, are you okay? Batiste, Arisa? Okay, so the trick now is to check and see what it does, right? Right, and you don't want it to stay a maximum, you have to just cut it down. Sure. Easy. That kind of easy. You need to remember all of this. That's very positive thing. Happy stuff. You remember all of this plus all the arts plus all the chemistry plus all the and it's that. Once you can handle something, stuff like that, we want to be in coordinated and difficult. So we manage everything. All right, so I've given you one under this type now. Well, another, well, I should have put number 4 here. So you wouldn't know what it is, right? So number 5, I want you to solve x minus 1, 2 minus x. That's not 0. Which one? This? So I want less than 0. Less than 0 is everything shaded down here. So all these values for y lie between this x value and this x value. X is more than this and x is less than. X is more than, x is less. Check it first. If the max, you know what to do. I expand it out and then check and see, right? Yeah. Just right and then you have it. Take your time, solve it out. All right, let's hear this one, right? Yeah. So the first thing I'll do, I'll multiply it out. X by 2, 2x. X by minus x. Minus 1 by 2. Minus 1 by minus. Right? So I'll get minus x squared, or I'll put the x squared first. 2x plus x is plus 3x. Bring down the minus. Right? This is a maximum. I don't want that. So I'm going to multiply by minus 1. And I'll get x squared minus 3x plus 2 is more than 0. Right? And then I'm going right ahead, find my critical values, and I'll get x's 1 and 2. Right? Then do a quick little sketch, please. Remember, 1 and 2 positive. So the curve will be on the right side. Okay? So do light touch on the left side here, right? 1, 2. All right. And then the one more than 0, so that's here. Okay, these two values positive. So it should be more to the right, all to the right. Here, one was negative and one was positive. So that will go for that, right? And question said more than 0. So x is less than 1 together with x is more than 2. Online. So again, you have it. Right, then we can pull up everything now. Pull up and see what we're getting. Double. Have one more side. For this somebody pass it as well. Then somebody can read it. So, pass. And let's check all this stuff before you talk here. All right, this one. All right, now we have time and I want to do this whole thing from 2013. You do a number 2, A and B. 2013, number 2A and number 2B. That's what you see in there, right? Ignore this, right? Ignore the part underneath and ignore the part on top. Right? You do it 20. But not that's really good, right? Right? So that's kind of how your question looks sometimes, right? We still have to do one more thing as a fraction, right? Which really easy. And I'll show you that now. I started to check it to make sure you have the first few parts correct. A is 3, B is 6, C is -1. Right away, define H and K. H is B over 2A. So I got 6 over 2 by 3, which is 1. So we'll pick that up H, right? And K is C minus A squared. C is -1, A is 3 by 1 squared. I got -4. Yep. So the answer is 3 by x plus 1 squared -4. Right? Minimum value. I told you that the minimum value is always key. So the answer is -4. Right? That's always a minimum value. And x value that gives you that is always -h. That's -1. That's all right. That's easy marks, right? Go ahead and solve the quadratic on it and without. Is that quadratic minimum? Yeah. Right. Did you get to? That's always the key. The minimum value is always key, and the x value that gives you k is always minus h. All the time. Every time you see that, it's always k is one and the next one is minus. Check back in notes again. Oh yeah, so the last part, so well, going to lunch. Right down, if you want to go on to this last one here. Is that right? And is that right? All right, nice. Good. If you want to go out, I was joking. Yeah. Sorry. Huh? What should I? Here was put together. Well, and higher, and I might give some more experience. Oh, you have to write the equation and then do. So the minimum and the critical values are. Right, the minimum and the critical values are minus 5 and 2 and 1. Look at that. Right. Now she got to do a sketch. It's more than 2, right? So she was bigger than k. Right? And then write the answer. So she shaded more than she got an idea answer now and she down. I just need to put it. And I'm blocking the board with that. Very good. Less than or equal with x to 1. Less than or equal to with x to 1. More than Very good. You're okay with it? So you have online, you're okay with this? So you should have this button. Good. With this, you're okay with this? Alright, so that's the way you do inequalities. Next day we do rational, and then I give you a few hard ones, right? One more thing in quadratics and we done. Alright, then we can go on to some long term. So you'll do it now? Cool, advance.